Hello, everybody. Let's go ahead and get started because we're already starting Pippa's presentation 5 minutes late. This is going to be a really exciting presentation. Thank you, Deputy Administrator Jackson. Thank you, Commissioner Jaworski. Thank you, other panelists. Shahid, great presentation. With that, let me reintroduce. So Pippa's already been on a panel at the conference. She's one of the people who's doing double duty. Pippa Brashear is a Chief Resiliency Officer for Chief Resilience Partner Principal at SCAPE, Landscape Architecture. For those of you who don't know of SCAPE, SCAPE won the design competition for the Living Breakwaters project outside of Staten Island after Superstorm Sandy. And they have worked on the Mid-Barataria restoration in Louisiana and other places besides. And your very popular presentation yesterday, and this is going to be an even expanded, bigger, and better presentation. I've been really looking forward to it. Saving the best for the last. Thank you.
Thank you, and I try not to keep everyone from drinks. So I think I met most folks here, but if I haven't, I'm a landscape architect and planner. I work at SCAPE. We are a landscape architecture office based in New York, New Orleans, and San Francisco. I am based in New York City, although I was born in Gainesville. And we are doing work in Florida, worked on the resilience plan recently in Jacksonville, as well as a large-scale stream restoration there, and in Tampa Bay, have not worked in Miami-Dade. But we really do landscapes of all different scales. But why is a landscape architect here talking to you? I kind of talked about the approach to our work and types of our work yesterday, but to reiterate, we kind of pride ourselves in being eco-aware, collaborative, engaged with both the people and the places that we work, and also really thinking about systems thinking. And I think that's key in this concept of resilience. This is just literally a list of like a bunch of our recent work that has resilience in the title. And one of the questions that I always get is, what is resilience, right? And I think that when we talk often about resilience, we're often talking about physical resilience, and often being equated with risk reduction. And I want to emphasize, I don't think it's just risk reduction. That's a piece of it. But I also want us to think about ecological resilience, sort of our landscapes and ecosystems, and social and economic resilience, because we kind of have to be resilient on all these fronts. So I'll just put this up. When I'm talking about resilience and I'm talking about a project being resilient, is really this idea, and this comes from the now defunct 100 Resilient Cities definition, I believe. But this ability to survive, adapt, and thrive in the face of shocks and stresses. So it's not necessarily about climate change. It's like despite climate change. And I want to emphasize that word thrive, right? Which gets at what I talked about yesterday is, where do we want to be, right? The other piece that we're increasingly working with is this idea of working with nature for climate adaptation and nature-based resilience and infrastructure. And I just put these definitions. The Army, what I've noticed, actually, the federal agencies have slightly different definitions of this, which is kind of funny because they're all supposed to be supporting and funding the same thing. But basically, there's natural systems and then this nature-based features, which is like uses or mimics or works with nature to reduce risk and provide other benefits. It's pretty broad. We can get into a deep argument about what is and isn't nature-based infrastructure. Some people would not call this nature-based infrastructure for certain reasons, but this is the project I want to talk about today. And this is not to say that it's copy-paste replicable to Miami. I don't think it is. But I hope it gives you a window into sort of how we take this concept and idea of designing nature-based infrastructure and implement it. It's in construction. We're scheduled to wrap up construction fall of this year. The contractors technically have until the end of the year, so we'll see if they get it done ahead of time or not. They say they are. But we really look at this as a model for scalable nature-based adaptive infrastructure. I want to go back. Our approach to this project actually predates Sandy and many ideas that we were thinking about, but the trigger, the impetus, the release of funding for this is Sandy. You guys experience a lot of hurricanes. The biggest hurricane in our recent history in New York was Hurricane Sandy, and it was quite a wake-up call. $50 billion worth of damage in New York City alone, or the region. It was very rough. I could burden you with many many stats and images. But one of the things I want to emphasize is at that time, and I think this is something that happens in Florida as well as New York, there were a lot of maps being made, like the one on the left, red, where it flooded, what was damaged, the cost, the this. And I think what people started to lose sight of, how big a wall do I need to wall to keep Sandy from happening again? And I think what people kind of forgot for a minute, and we really wanted to call attention to, was our water bait, like the heart. If not for New York Harbor, there would be no New York City. Like, we exist because we're on the water. The whole region does. It's the lifeblood of our, the port is part of like our history, our identity, but our economy in the past and future. And it's just part of the ethos and identity of New York, right? You go out and Statue of Liberty. So we wouldn't be there. And so when we had this opportunity, one of the things in the Sandy, the disaster funding, was there was a unique program called Rebuild by Design. It was a design, I think, partly from the fact that then HUD Secretary Sean Donovan was an architect, but he also teamed up with Henk Oving from the Dutch Embassy to run this program, which set aside $1 billion of Sandy funding to go towards projects that were generated out of this creative design process. And the premise was they were interdisciplinary but design-led teams, and we embarked on this like many-month-long process where we didn't start with a specific site, but actually kind of worked through some of the challenges that we were going to address to develop projects. And our team was really keenly interested in this problem of like not walling off the water. That was the premise that we started on, and looked at landscapes around the region. Because sure, there are going to be some places where you just need to sort of engineer your way out, like Lower Manhattan. But there's plenty of bay landscapes that combined, exposed shorelines with nearshore habitats or ecosystems that are degraded, and waterfront communities, water-based communities who have sort of a history, identity, or economy that's really tied to the water. And so we said, can we create something that brings these together, that combines real, quantifiable risk reduction with ecosystem enhancement and social resilience. And ultimately, there were many ways that we got here, but the project of ours that came out of that was Living Breakwaters, which was this necklace of breakwaters that, they're rubble mound structures that break waves, reduce erosion, and provide habitat. And I'll get into some of the technicalities of how we did that. But at that phase, this was the vision, right? It was a competition vision. Luckily, we were pretty convincing. The state of New York was awarded $60 million to do this. That's not the full cost of the project. Our estimate at the time was $74 million in construction, so the state got 60. The construction cost, last I got it, was $78 million, so that's pretty good, especially if you consider that this estimate was done in 2015 and $2015, and now it's 2024. But the reason that I want to kind of walk through this with you is this concept of having a big idea and a vision about how we might adapt, going through a process to design and permit it, and getting it built. And how do we kind of think through these themes of nature-based infrastructure that I talked about yesterday, of reviving ecosystems, of cohabiting our environment, engaging people, and scaling it up through this whole process, right? How do we do that? How do we fill that diagram? So what does it mean to kind of revive landscape systems for risk reduction? This is what Staten Island looked like after, or South Staten Island looked like after Sandy. There were a lot of deaths in Staten Island. In this neighborhood specifically, there were 2 because of wave damage. And what you can see is, there's a big difference. The houses in the back were damaged, but the houses in the foreground obliterated, right? Because they were the breakwaters. But what we also realized through analysis over time, both looking at historic aerial land map changes, as well as just talking to people, is there's been massive shoreline erosion over time. We started to kind of dig into why that has happened. And it's actually not surprising when you start to talk to coastal engineers and hydrodynamics. Staten Island is positioned right across from the New York Bight. So when Sandy came into New York Harbor, it just pushed water and waves here. Actually, storm surge elevations were much higher here in the south and east shore of Staten Island than in Lower Manhattan. But why wasn't this a problem in the past? So we started kind of thinking and looking historically for understanding and reformation. If you looked at this map in the 1800s, or 17 or 1800s, this is what it looked like. There were these sort of extensive shallow water habitats off the South Shore, including the sort of blue bubbles, which are mapped oyster beds. And these actually, they were really a vibrant part of the economy. Actually, the town at the tip of Staten Island where we're working was literally nicknamed Tottenville, the town the oyster built, because oyster fishing and oyster farming was such a big part of the industry, which was a huge industry in New York before it went into decline and decimated the oyster population. Now there are no more reefs. And actually, it was studied by Dr. Phil Orton at the Stevens Institute and others looking at modeling that if you look at the sort of top is with today, historically, and the difference that the wave attack, the erosion that this was experiencing is significantly less than it was. So this was this idea, how do we revive that system? We can't put the oyster reefs back now. There's the habitat restoration dynamics of that would take 100 years. There's a lot of effort to restore oysters, but we're just not there yet. Also, it would require large amounts of fill, which would not be permittable in New York Harbor. So, but what can we do? Can we create structures that provide those same function, that risk reduction function of wave reduction? But that was a concept, right? That little we can draw this diagram and show it, but how do we make sure that it works and it provides the risk reduction that we need to actually take that coastal environment out of the V zone below the limb wall so that we're not getting that additional wave damage? And we did look at those numbers. And so increasingly refined hydrodynamic modeling, wave modeling, right? And we did this in an iterative process. This is something you really have to think about because, Carrie, as you alluded to, these models take a long time. And part of the reason we actually were able to do some of these because of computing power, but we also did simple sort of understanding of the wave dynamics, then a ref-diff model, which might take a few hours, half a day to run, to the fun wave models, which actually took 24 to 48 hours to run, which you didn't want to be doing iteratively. We also looked at two-dimensional shoreline change models that looked at if you put the breakwaters, this is actually kind of more complicated. The waves are a little bit logical, but how the shoreline responds to putting these in the water is really kind of hard to model. And so we really had to do that iteratively and test some dumb scenarios up top, right, that we wouldn't necessarily do to start to hone in on what the right configuration was to get that. So that's all to say, and then we also did physical models, and that's really if you're trying to figure out how it's structured, if that structure is going to work in the water and hold up to waves. The way that coastal engineers do that is to actually do physical models in a wave tank. So that that's where we ended, and then you put it in the water, and so I think just this how do we get these? We talked about the complexity of the models and understanding the dynamics, but to take that down and translate it into something that's physically going to reduce risk and do that in a specific place is actually a a whole different set and iteration of models. And I'm going to talk about this project, but this concept of how do we need to understand and model landscape systems to understand how they reduce risk and understand what we can do to revive is relevant in other contexts, right? This is the one I talked about yesterday, where can we manage marsh elevations to reduce wave risk, right? And looking, I needed to throw in a Florida example. At Eckerd College, we did look at a lot of elevation strategies for their campus, but also where could they extend and expand and create space for habitat migration and mangrove expansion, which was going to provide that same attenuation benefit there. But part of that system that we're reviving was also the ecosystem services. How can we kind of use this? If we're going to put something in the water, also if you're going to permit something in the water and you're going to reduce risk and you're going to do all this work, what are the other things that you want to do? And one of the goals in this area is actually shallow water habitat restoration. And how do we sort of start to design to cohabit and create space and environment for these creatures, right? First step is, who are we designing for? Right? I think we talk about ecosystem services and habitat in the abstract a lot, but it's very specific if you want them to function, right? This is an abstract map, but what we did, and there's a much more technical version of this, but really categorized different target groups of species with specific species and mapped to sort of what their structural habitat needs were and where they might inhabit the breakwaters over different stages of their life cycle. And so, but there are some sort of general principles here that we notice for all of these. One, complexity. Complexity in structure of habitat will provide, complexity and biodiversity there. So we wanted to have lots of niches and crevices of different scales, which is a little counter to a lot of engineering. Engineers want everything really uniform. So it stands up. And then we said, what's really one of the things that's really interesting in reefs, that's true of oyster reefs, of coral reefs, are these spur and groove formations. There's sort of commonalities in structure and formations that you see in many, many types of reef structures. And so, how do we sort of start to just make and create that thing that informs naturally over time? And so we were able to do and design that. These are built largely of rock because, well, that's what the industry can do and knows how to build effectively. And rock creates most of those niches and crevices. And we actually found studies that said, breakwaters in England that have been there 100 years have like good fish habitats. We said, why do we need to change that? But there are ways that we could sort of kickstart other habitats. So we did strategically use ecological concrete units that had treatments, and ultimately we got some oysters installed in them in the subtidal zone. And then these, I think I have some other pictures, but you see it popped out, these artificial tide pools, which hold water in that intertidal zone. And that's really important. It just creates more diversity, right? Hold water and actually extend what happens in the intertidal zone that you kind of didn't have before. Right. And this is one of the areas where, the construction isn't done. We haven't officially started the monitoring, but the engineers are out there inspecting that things have been built right and stuff all the time. I mean, I go out there, but I'm not a certified diver, so I don't get to do the underwater ones. But there's stuff growing on them. Like literally the contractors are like, okay, you guys, you can't wait more than a week to look at the marine mattresses because they're going to have stuff all over them and you won't be able to tell if we installed them correctly. So I think this has been one of the, and the bald eagle perching. Yes, I told them to send that to HUD. Lots of, the only result is they smell really bad because there's a lot of birds on them and they poop a lot. But we're really seeing this vibrant life already in an active construction project. So, and we I've showed this picture before and we like to show it because we got a lot of questions like, why are you showing harbor seals? They're not going to be here. But they are. And so, if you design for species, you can attract them. The other thing, and I think I added this slide in yesterday, but I wanted to highlight, we're not supposed to call this a pilot, but in many ways it is a pilot. And one of the things that we did with these ecological enhancements is to actually lay them out in a way, work with our ecologists to make sure that the deployment of these features were statistically significant if you went back and monitored them, and also made sure that there was one breakwater that was a control and that had different features. So we're going to be able to monitor them over time and tell the relative benefit of some of these features. And safe space, maybe some of them don't have a marginal ecological uplift, but I want to know that so that when we do more projects like this, we're not just, it's a great idea, let's do it and trust it. No, we should monitor it, we should look at it, we should see how it's doing and which one of these features are better or worse. So in a couple of years, probably I don't know how long it takes, 5-10 years, be able to sort of see what has more or less benefit. And this, this is a big infrastructure project, but this kind of approach can apply and scale down. It was in many ways inspired by, a sort of smaller pilots that we did, this aptly named fuzzy rope, where we basically put fuzzy rope in the water to attract fouling organisms and habitat in an effort to kind of understand how you can modify hard structures. So I think, I'm focusing on nature-based infrastructure, but one of the things that we've learned from building the breakwaters and other work is there's a lot of ways that we can modify and adapt our harder infrastructural edges to actually create habitat. And there are some principles like the sort of complex surface complexity. You see pulling this off of the actual edge or bulkhead to let light penetration into that shallow water. Those are all things that we can apply and use. But in the end, it is about people and this idea of engaging people. And one of the big things that, I want to emphasize is we did a lot of engagement in the process of bringing people on board and helping them understand what the project would do and answering questions in the traditional sense. But what the intent here when we talk about engage is not like just engaging for engagement's sake and for the public process and a design process, but actually engaging people with the landscape, with the harbor, and getting a better understanding of risk and resilience. And so from the outset, the idea was that this project would connect and tie with schools at the waterfront. And we early on had a partnership with the Billion Oyster Project, which is a nonprofit organization in New York that bills themselves as 50% restoration and 50% education. They call themselves that because they are going to restore 1 billion oysters to New York Harbor, but they're using that as a teaching tool. They develop STEM curriculum and run science-based programs in middle schools throughout New York City where they use New York Harbor. Why should kids in New York City be learning about ecosystems that they've never seen or visited? So they actually are able to kind of work and understand life cycle biology. There's also a high school called the New York Harbor School that's on Governor's Island. And I was like, why could I not go to a high school like that? And I was like, you can major in like scuba diving. But so a lot of the outreach was paired with educational activities like this. And through the process, it became really an educational program, but also stewardship programs on the beach that really built up over time and will continue throughout. The partnership with the Billion Oyster Project is they will actually install and monitor live oysters on the breakwaters too. So part of this engagement program was actually piloting many of the techniques. This is one of the pilot events that would ultimately go on the breakwaters. And I think this kind of process, we cannot underestimate the importance of this kind of process in resilience and adaptation, because all of those complexities about uncertainty, about how we understand risk, about how the water connects to me, that's so important to actually getting engaged constituencies around this to kind of share their needs and risks, but also advocate for projects. It comes from this. Like, this is the sort of social infrastructure that I think we have to be able to build. The other thing is we did actually develop a curriculum on this with the Billion Oyster Project, which we wrapped up in, when did they post it live? February of 2020. So it was a very helpful thing. A lot of kids actually learned science with this, when they were doing a lot of online learning in 2020. And I think this is something I just want to say that we really bring to a lot of projects and all our projects, and can't emphasize the importance that we think about this communication, this engagement, not from box checking or just, hey, what do you want? Tell me what you need, but really sort of building a shared understanding about our landscape and urban systems. This is Town Branch Water Walk in Lexington, Kentucky. I think I mentioned it before, but it was a stormwater management and trail project, but really was about daylighting too. And ultimately there's sort of education and wayfinding about interpretation as part of the finished project, but it really built up as part of the whole process. And it's another one of those long-term infrastructure projects. And I think as we sort of these, federal funding comes down for these infrastructural projects, how we sustain people's understanding and interest in that process and the project and not kind of lose faith in what we're all doing is actually a really important part of it. So what does it mean to scale up and to take these? One, I think just getting it done. So originally in the competition phase, this was part of this idea. Okay, this is a replicable strategy that could be done, right? But that process, so we had these diagrams, but there's only one funded right now. So we don't know what that will happen. But the process, what can we learn from the process of this that can be, frankly, maybe changed some in order to adapt and replicate? So I think it's really important to understand how we went from this competition, from HUD CDBG-DR funding to the state, who was involved, how is it permitted, who were the implementation partners, and how did that all happen and come together, and what worked and what didn't work and what took too long. And who do we talk to as we try to scale up and implement these ideas? We've talked a lot about regulatory reform. This is the EIS for the project. I would say, so what did I say? The competition ended. We got the announcement of the award in 2015, contracting, procure. It was basically 2016 before we started it, 2019 to design. Still wrapping up permitting, value engineering, went into construction in 2021. That's a long time. My husband would live are your rocks in the water yet? I built half a city in Lower Manhattan in that time. He works in zoning and land use. So I think this is an area, this is a wicked problem that we kind of need to solve, right? We need to protect, we need the environmental regulations to protect the natural ecosystems that we have, but we need to be able to move projects effectively forward. Yeah, so I'm happy to have conversations about reform of the environmental review process and permitting challenges. And I'm actually on a lot of like sort of committees and working groups in New York City right now to try to handle that conundrum. But the other thing about scale is I'm here today talking to you guys about this. Whether it's because of this project, whether it's because of HUD, whether it's because, Kate won the MacArthur and who's our founding principal, but like it's really inspired a lot of interest, both locally, that's, Walk on the Beach. We did an installation at the New York Historical Museum. I mean, this is someone who was, trying to promote some of the early public meetings. And one of our colleagues lived in Staten Island. He was like, great promo from Staten Island. We're like, we didn't plan that. That person, we didn't ask anyone to do that. She just did that. She's really excited about the project. And it's received international awards. And so I'm really interested in, the scale of, how do we learn, how do we share lessons learned to kind of do more projects like this that have these multiple benefits. The point also being that these don't act in isolation. We've talked a lot about adaptation, mitigation, what should we do? And one of the things with these is it's not singular, right? This project is not a breakwater project. It's part of a layered approach to stepping down risk, right? This isn't keeping the water out. The low density neighborhood in South Staten Island, it's never gonna pencil out to get a seawall. Also, you don't want one because how are you gonna maintain it? Who's gonna pay for that? This is one of the premises is a low maintenance piece of infrastructure that was going to sort of work by itself to reduce risk. What that means is people are gonna still have to adapt homes on land and do some of the mitigation measures, mitigation small end in the adaptation world, not carbon mitigation, although we should all be doing that too, that kind of builds a culture of resilience and starts to say that we do have to change. We individually, I have to change my behavior, you have to change our behavior as part of adaptation, but there's also infrastructure that we can build to do that. So I think one of the prompts that I wanted to ask is, we've talked a lot about, how do we price these things? How do we pay for adaptation? And I think one of the things to consider is, it's very hard to figure out exactly what the number is, right? But are there things that we can do that we can say will definitely reduce risk, but also provide all of these benefits and services that we want anyways, and we would pay for anyways? People pay us as landscape architects to do educational programs, design communication, to build parks all the time, right? What if they also, provide that risk reduction benefit? As we think specifically about natural and nature-based infrastructure, I think it's important because of, we have a biodiversity crisis as well, but also this understanding that these systems are not entirely self-sustaining, but much more self-sustaining than some of the sort of flood walls and gates that we do. What are the equivalents in South Florida, right? What does it mean to revive? We've talked a lot about mangroves. Is it mangroves? Is it the whole hydrodynamic system from Lake Okeechobee to the bay and the Gulf? How do we? And I borrowed this from someone I'm doing a panel with at Miami-Dade County later. How do you, if you think about those ecosystems, how do you cohabit? How do we combine urban living in Miami with restored mangroves? How does that cross section and that development and land use look? And what do you need to do? What do you need to do as policy or regulators to unlock that? Right? I understand, and I don't know if this is the right one. I just was looking, and I understand there's a bill right in the Florida Senate to make it easier to restore and preserve mangroves. What are the steps here? And I think that's something to start thinking about. So thank you.
Fantastic.
We can talk over drinks.
So really love the work that you do. Really find this fascinating. I could hear hours of this presentation. Did anybody have any questions for Pippa?
I know that there's interest in living shoreline. I know that was one of the demands when the first rejection of the Back Bay project in Miami was like, we want more natural infrastructure. But I get the impression that there's also rather significant resistance to it, and I have yet to understand where it's coming from and for what reason.
I think it really depends on the place and scale. So the reality is, and a lot of the nature-based infrastructure was dismissed in kind, I think, from the initial Miami study, but also our HAT study, which is like the Army Corps equivalent in New York State and in New York City, and we just had them say that they're going to go back and look at it. Partly because the way that those flood studies were done is basically to reduce risk from a 100-year storm. So, I mean, you saw, like, we can knock down some waves, but you've got to build miles of marsh or mangroves to do that, right? So you can't entirely keep the flood waters out. And so I think we need to be very honest about where and how nature-based infrastructure works and doesn't. And, this is a nature-based on the more engineered scale, but to do the sort of truly nature-based, it really has to be at a big scale. And so I think there's a lot of one of the resistance you get is from, just they don't provide total risk reduction, right? In terms of keeping out floodwaters from a 100-year storm, right? I can't get my insurance benefit from that. Although the flip side of that is, and one of the things that does work is, if the storm is 2 inches higher than your flood wall, what happens? Well, you're really screwed. If it's 2 inches higher here, it still attenuates waves, just not quite as much. So that's on the benefit side. The other pushback that we get is, you could say it's from the development side or the regulatory side, is that, in a lot of places we've hardened our shorelines, and most nature-based infrastructure on the shore, you need a shallow slope. So you either got to go out, and the Army Corps and your environmental agency are going to say no, or you got to go in. And your waterfront development community be like, no way, don't take that floor area away from me. So it's really hard. And that's why I think we've really focused on preserving the shorelines that we have. In the smaller scale, I know there's been some pushback on living shorelines in sort of like smaller, more residential, like Back Bay, like you're in Wilmington, so along the Intercoastal Waterway and stuff. And I think that comes from a couple instances, sometimes misperception that like the harder shoreline is going to do better, or boat access. And the problem at that scale is often that, if I build a living shoreline, it's great, but if the person over here has a revetment and a seawall, it's just going to erode. And so I think the scale at which we implement that is a real challenge when it comes to living shorelines. Yeah.
Hang on. Sorry, Shahid, hang on.
Duration? That's a really...
How long do they last? For example, in Venice, they build the barrier, right?
Yeah.
For these things. But it has a certain lifespan. It's
Yeah.
going to rust.
I'm going to be really glad.
And so in Miami, there were some proposals to build similar
Yeah.
barriers. You don't want to do it too early because you build it, and the change hasn't happened yet.
Well, this is going to reduce...
It's just going to rust.
This is going to reduce risk now, right? So, and it's not a barrier. It's not keeping the water out. So the performance, the design lifespan that and I'm going to call it the performance lifespan, because the performance lifespan for this really has to do with the target performance was to change the erosion and to get that storm wave reduction down below 18 inches before it hits shore, right? The limit of moderate wave action, not to damage houses. So the lifespan that we said was 50 years, but that's really just the performance based on the sea level rise projection. So that's about 30. You can accommodate about 3 feet of sea level rise before a 1% annual chance storm is going to have waves higher than that might get through. We looked at a lot. Part of the reason we picked this, though, is breakwater, they're just really durable. We did there are breakwaters from like the 1700s in the UK that are still there, and also Japan. And we were trying to answer this question because we got a lot of questions from the agencies about like, what is the maintenance cost going to be? And I don't have it in front of me, but there was a study from the Corps in the early 2000s that looked at like 15 breakwater systems up and down the East Coast. And I think it was like the most expensive one had like $1 million in maintenance costs over 200 years. Like the construction was like dating from like the history record was dating from 1850 to 1980. And like there were only 2 that had significant failures, and it looked like they were mostly due to like not being constructed right. I mean, they're highly engineered. Every rock is placed, but in my husband's words, they're piles of rocks in the water. They're pretty low maintenance and pretty durable. But.
Great presentation. I really enjoyed it. I have a question. I saw you had the Corps and the Army Corps of Engineers as a partner. And I know with like Back Bay and in Miami-Dade County, one of the things that influenced getting a wall as opposed to more natural infrastructure the first time around was the cost-benefit ratio that the Corps uses. Yeah. And I know there's been some discussion and even some guidance on the record that states that we have to better quantify the benefits of green
They're actually
infrastructure.
mandated to do that now. So yeah.
And it's yes.
I haven't figured out why it's not coming down to the local things, but this is not a Corps. They were not a partner.
Okay.
So the Corps, in coastal infrastructure, the Corps wears 2 different hats. They are builders. The Corps Civil Works are builders, but the Corps also has a regulatory, and they're the regulatory enforcers of the Clean Water Act. So that is their involvement in this process. And actually, part of the reason that this even happened is because the Corps is not part of it, partly because that benefit cost ratio. We did have to do a benefit cost ratio, and I was realizing as I was hearing today, I was like, I probably should have pulled all that stuff up. It wasn't me, it was economists. It was done twice as part of the original competition in a very conceptual way, and then as part of the HUD. But HUD doesn't have the same requirements, so you could kind of make your own benefit cost thing. So, anyone can make any benefit cost ratio work, but we did do one, and we did get a positive BCA. We did do ecosystem benefits, but it actually wasn't a huge contribution to the benefit cost relationship here, partly because of, I think, some of the points I made yesterday, like the economics they're always undervalued and they're really hard to quantify. But we did get benefits from direct damage reduction anticipated from homes. A big part of it came from avoided loss in city parkland and reduction in loss of life, as well as some of the ecosystem benefits. So we did do that. It came out, but it would not have penciled out in an Army Corps BCA, just in terms of what you can and cannot value in that metric is allowed. So
thank you. Appreciate that.
There's a effort that started last year called Measuring Success that the Water Institute did for ERDIC at the Corps, looking at how to revise that BCA. I know there's an active process ongoing with the Army Corps to revise the BCA process. So, yeah.
And that concludes FIU Environment Forum 2024. Thank you all for coming. Thank you so much, Pippa.